Hi Math 30s. This video is going to cover lesson 4 in your workbook in Trig 1. So this lesson is on page 523 of your student workbook, and I will do this lesson in 2 parts, just as the workbook is done in 2 parts. One thing I just want to mention, the majority of this lesson, almost all of it, is going to be a review for Math 20-1. The only thing that's new is that we're going to be doing the reciprocal trig ratios in this lesson. So what this lesson is on is based on a trig ratio that I give you, we're going to determine an angle. So how we do that is we have these 4 steps here. So you want to maybe highlight these 4 steps and just star this as notes. So I will go through these 4 steps when we go through the first class example. But if ever you need to sort of review what it was or you need to put it on your study sheet, you have that here. For all of these, we are going to be looking at determining which quadrants we're working in. And in order to do that, we're going to be using our CAST rule. So you might just want to write CAST there. So for each question, you're going to draw yourself a Cartesian plane and you're going to write CAST. So let's look at the first example and see what it looks like. So class example number 1. Complete the following to solve for the cos of theta when the ratio is negative 0.5, and then it gives us the domain. So a few things about this domain. The first thing I want you to note is because this is in degrees, your calculator must be in degree mode. So just go over to your calculator, make sure that degree is selected. If you're in the wrong mode, you'd get the entire question wrong. Okay, so cosine of negative 0.5, what we want to do according to step 1 is we want to determine the quadrants the angle will be in by looking at the sine of this ratio. So you always want to draw yourself a Cartesian plane. And let's do our CAST rule. So C-A-S-T. We need to check off the quadrants where cos is negative because that's a negative ratio. So cos is negative in quadrant 2, which is the sine quadrant, and quadrant 3, which is the tan quadrant. Okay, so the quadrants that we're dealing with are going to be quadrants 2 and 3. In order to get the reference angle, what we're going to type in is the inverse cos. So this would be something you learned in grade 10C. If you want to get the angle, how you type that in on your calculator is the inverse cos of the absolute value of this number. So this is going to be step 2. So we would take the inverse cos of the absolute value of negative 0.5. So the absolute value of a negative number is always the positive number. So I would say 0.5. And let's figure out what that reference angle is. So whenever we are figuring out the angle, it always gives us on our calculator the reference angle. So second function cos, so that's the inverse cos of 0.5. That gives me a reference angle of 60 degrees. So that gives me 60 degrees, and that is always going to be theta r. So my reference angle is theta r. Then what we have to do is within these 2 quadrants, so in quadrant 2 and in quadrant 3, we have to figure out what the rotation angle is, and we're essentially going to have 2 answers. So I know that one of my answers is going to be in quadrant 2. So what I would do is on my Cartesian plane, I would draw an angle, and I need to find out what this rotation angle is based on the fact that it has a reference angle of 60 degrees. Okay, so I know that this is 180 degrees as a straight line, and in order to get that rotational angle, I would take 180 degrees minus 60, and I would get a rotational angle of 120 degrees. So theta here is equal to 120 degrees. That is one of my answers. So one of my answers is 120 degrees. Okay. My second answer, so I'm going to draw a second Cartesian plane for the next one. I know that cos is negative in quadrants 2 and quadrants 3. So now I've got to go to quadrant 3, and I need to draw my rotational angle in there. I need to figure out what this rotational angle is. That's what they want, okay? But in order to figure that out, I first need to put in my reference angle. So the reference angle was 60 degrees, so I need to put that in there. And then I need to say, okay, how do I get the rotational angle? 180 degrees plus 60 degrees will give you a rotational angle of 240 degrees. So the second answer is 240 degrees. So how I would state my answer is theta is equal to, I've got two answers, 120 degrees and 240 degrees, and then you could box that in. How could we check that we were right? What we could do is, if I know what theta is, I'm going to type on my calculator the cos of 120, see what that equals, and I'm going to type in the cos of 240 degrees. And what answer I'm looking for is negative 0.5. That's the answer that I want. So on my calculator, the cosine of 120 degrees is negative 0.5. The cosine of 240 degrees is negative 0.5. Okay, so we did that question correctly. Let's look at class example number 2. So we've never seen this written in 20-1. So what they've given us is they said what they want you to realize, so I've got this highlighted, if you see the sine of theta squared, how that could be written is sine squared theta. Okay, so first thing I just want you to realize that sine theta squared is equal to sine squared theta. Now that we know that, let's take this and write that equation. So the sine squared theta is equal to 0.5. We need to basically isolate sine by itself. And if you could sort of see it a bit better on this side, but if I said, well, how would you get rid of a square? You would square root, right? So how I get sine by itself is, in order to get rid of a square, I would square root. So I'm going to square root this side, and I'm going to square root this side. According to the square root principle, when you square both sides of an equation, you get plus or minus the answer. So my answer is positive square root of 5 and negative square root of 5. Okay, based on that, we are going to draw our cast rule, right? So let's draw our Cartesian plane, and let's apply our cast rule. And then you need to check off the quadrants where, let's first check off where sine positive. So where's the sine positive? And sine is positive in 1 and 2. Then the answer is also, our trig ratio is negative square root of 0.5, which would be in quadrants 3 or 4. So this question actually is going to have an answer. We're going to have 4 answers. We're going to have an answer in each quadrant. So once you figure out what quadrants we're in, the second step is to determine the reference angle. So in order to determine the reference angle, what you're going to do is you're going to take the inverse sine, the inverse sine of the absolute value of this number. So the inverse sine of the absolute value of, and then that would just be 0.5, because the absolute value of this negative square root of 0.5, we just write the positive number in there. You basically write whatever the ratio is with no negatives. That's how we always do the reference angle. Then I'm going to look at the top, or am I in radians or am I in degrees? And this domain restriction tells me that they want my answer in degrees. So I'm in degrees on my calculator. So let's figure out what the reference angle is. Second function, sine of the square root of 0.5. And that reference angle is 45 degrees. So 45 degrees is equal to theta r. Okay, What I now need to do is I need to put that 45-degree reference angle in each of the 4 quadrants, and I need to find the rotation angle in each of the 4 quadrants. So quadrant number 1, if I have a reference angle of 45 degrees, and I say, what's the rotation angle? Remember that in quadrant 1, the rotation angle is equal to the reference angle. So one of my answers is going to be 45 degrees. So I'm just going to write that down here. Theta is equal to 45 degrees. Okay, in quadrant 2, what you could do is you could draw yourself another Cartesian plane down here. I'm just going to erase this. In quadrant 2, I need to put that 45-degree reference angle in quadrant 2. So this is 45 degrees. Remember that it's always the angle formed from your terminal arm to the x-axis, right? That's always your reference angle. So they want this rotational angle here. So you would say, okay, 180 degrees minus 45 degrees would give you a reference angle of 135 degrees. So this second answer of theta is 135 degrees. Draw yourself a third Cartesian plane. So draw yourself a third one, and we're going to put a 45-degree reference angle in this quadrant 3. So I'll erase this. Draw yourself a terminal arm. The reference angle, remember, it's always the triangle that goes up, the acute triangle that always goes up to your x-axis. So 45 degrees is right here. They want to know the rotational angle, which would be this angle here. And in order to calculate that, it would be 180 degrees plus 45 degrees, which would give you 225 degrees. Okay, the last answer, because remember I was in all 4 quadrants, is where they could expect an answer. So now I have to draw yourself your last Cartesian plane, and we want to draw a 45-degree reference angle in the 4th quadrant. So what that would look like, there's your terminal arm. The reference angle always goes up to your x-axis, so 45 degrees is right there. They want the rotational angle, which would be here. Once around the circle is 360 degrees, and I'm going to subtract 45 degrees. So you type in 360 minus 45 degrees, and you would get a rotational angle of 315 degrees. And that would be your 4th and last answer. Let's look at class example 3 and 4 next. Okay, class example 3, it's going to give you this note. So you might want to, this is just something important to make note of. What they are saying, remember that from the last lesson, there's no calculator for the reciprocal trig ratios. So there's no calculator key for cosecant, secant, and cotangent. So for example, if I gave you the cotan of x is equal to root 3, and I said, okay, we need to find what is angle x. So that's how would you find that if you don't have the button? What you have to say to yourself is, okay, cotan is reciprocal for what trig ratio? And cotan and tan go together. So cotan is the reciprocal for tan. So how you would write this is you would say the tan of x is equal to, and to this guy, we would take the inverse of this. So we would write 1 over root 3. And then from there, we would take the inverse of tan, because on my calculator, I could type in the inverse tan of 1 over root 3. So just sort of make this note up here, because class example 3 and 4 are going to involve the reciprocal trig ratios. So based on that, let's solve this. So it says solve the cotan of angle x if it is equal to a ratio of root 3. So what I want to do is I'm going to do a few things, and we just sort of did this. Put that over 1. Then say to yourself, cotan is reciprocal to what? And cotan is the reciprocal of tangent. So the tan of x is equal to 1 over root 3. Once we have that, you always want to find your first step is in which quadrants is tan going to be positive, right? Because this is a positive ratio here. So according to the CAST rule, where is tan positive? So I would label off CAST and I would check mark the 2 quadrants where tan is positive, and that would be quadrant 3 and quadrant 1. So I'm going to have 2 answers, one in quadrant 1, one in quadrant 3. Okay, in order to find what the rotational angles are, we need to go on to step 2, which was finding the reference angle. So to find the reference angle, we would take the inverse tan of 1 over root 3. And again, this domain restriction tells me to be in degree mode on your calculator. So on my calculator, the inverse tan of 1 divided by root 3 is 30 degrees. Okay, so that's equal to 30 degrees. And remember that that is always the reference angle. So 30 degrees is always your reference angle. Okay, from there, I'm going to put that reference angle of 30 degrees into quadrant 1 and into quadrant 3, and I'm going to get my answers. I've got 2 answers. So in quadrant 1, if I have a reference angle of 30 degrees, what is the rotational angle? And the rotational angle in quadrant 1 is equal to the reference angle. So my rotational angle is 30 degrees is my answer. Now, I would not put theta is equal to 30 degrees. And the reason is you have to be careful with what they want you to call theta. And in this case, they want our angle to be called x. So I'm going to erase theta, and I'm going to put x there. So x is equal to 30 degrees is one of my answers. Then draw yourself another Cartesian plane, and let's put a reference angle of 30 degrees in the third quadrant. So the reference angle always goes here because we have to make that acute triangle, which goes to your x-axis. They want the rotational angle, which is this answer here. And we know that this is 180 degrees. 180 degrees plus 180 degrees plus 30 degrees is 210 degrees. So those are my 2 rotational angles that would have this ratio, right? So if you wanted to check that, let's type in the tan of 30, and let's see if we get 1 over root 3. So on my calculator, the tan of 30 degrees is that, and I'm going to type in 1 divided by root 3. I get the exact same number. And then I'll check the tan of the second rotational angle, which was 210 degrees. And I get the same number as 1 over root 3, which is 0.57735. Okay, let's do class example 4, and we'll only do one of them because it's sort of the same thing over and over again. So the secant of my angle x is equal to negative 0.12631. So you have to first know, in order to do this, what is secant the reciprocal of? And secant is the reciprocal of cos. So how I would actually write this is the cos of angle x is equal to 1 over negative 1.21 2631. So let me fix that. So negative 1.2631. From here, if I drew my let's find out where cos is negative. So according to CAST, cos is negative, because this is a negative ratio, in the second quadrant and the tan quadrant. In the sine in the tan quadrant, that's where cos would be negative, and that's where secant would be negative, right? They're both going to be negative there. After you figure that out, we need our reference angle. So to get the reference angle, we're going to take the inverse cos of the absolute value of this number, which just means type in the positive. Don't type in any negatives. So 1.2631. And let's see what we get as an answer. So I'm just going to clear what I previously had. Second function cosine of the absolute value of 1 divided by 1.2631. And I get a reference angle of 37.6, and I'm just going to look at the question, because the question actually says to the nearest degree is what they want the final answer in. So because they want this to the nearest degree, I'm going to give this reference angle as 38 degrees. So that answer is equal to 38 degrees, which is equal to theta r. So that's my reference angle. So they're not asking for the reference angle. I shouldn't have really boxed that in. What they're asking for is the two rotational angles. So they essentially want what x is. We have two different answers. One answer is going to be in quadrant 2 and one answer is going to be in quadrant 3. So in quadrant 2, I need to put a reference angle of 38 degrees. And that would be my acute triangle. They want the rotational angle. I know that the rotational angle is going to be 180 degrees minus 38 degrees, and you would get 142 degrees. So one of my answers for x is going to be angle 142, right? Because remember that these are angles there. Okay, the second angle is in quadrant 3. So I always recommend you draw yourself two Cartesian planes, right? So draw yourself like a second Cartesian, actually maybe I'll use this one. Draw yourself a second Cartesian plane. Let's put the reference angle of 38 degrees in here. It always has to be within that acute triangle that goes to your x-axis. They want the rotational angle, which is that there. How you get that is 180 degrees plus 38 degrees, and that would be 218 degrees. Class example 5, we are not going to do. So I'm going to come back to this class example, so don't cross it out. I want to show you the special triangles, which is the next lesson, and then I come back, and once we have our unit circle done, then we will go and we will do class example 5. So for your practice, it says 1 to 4, and I just want to see. Here's what I would assign. So I want you to do number 1. I want you to do number 2AB, number 3, and 4ABC. And that's based on this lesson. And then when you're done, you could come back and I'll do part 2.